My name is Bat-hen Nahmias, and I'm a postdoc at MIT. I did my PhD at the Technion with Yoram Shiftan, and I'm going to present an overview of this work. So the topic was, or the purpose was to incorporate equity considerations in transport project evaluation. And I'm going to present the main process of this work and the results, some of the results. So I start by saying that, as you know already, equity considerations involve great complexity, and this is why it is usually neglected, despite its great importance. And the most commonly used tool for policy analysis is cost-benefit analysis, leading to a focus on efficiency rather than on equity. Its limitation regarding equity consideration is the fact that it does not distinguish between certain groups or people, and it includes the potential for optimism bias. As a result, higher income groups are evaluated or get stronger weight in the evaluation process. So what we did in this work was to design two new measures. These measures were specifically designed to overcome cost-benefit analysis limitations. So this is an overview. The purpose was to incorporate equity and efficiency. Equity and efficiency in one framework. The three main pillars of this work is justice theories. So we did investigation regarding justice theories that was led by Karol Martens. And we studied transport modeling, and we used activity-based models as a main tool. And of course, we study economic evaluation and incorporate several measures like subjective well-being measures. The theoretical approach underlying these two new measures is the capability approach. And then we created two new measures. I'm going to describe them in more detail in a moment. And then we studied them in a synthetic case studies and in a real-world evaluation using the San Francisco Bay Area case study. As I said, the capability approach is the theoretical approach underlying these new measures. The capability approach is derived from the actual opportunities that people have given their personal and social circumstances. And transportation is the mean to reach opportunities that shape a person's capability. And since accessibility is a precondition to realize this capability, we are suggesting basing the evaluation on accessibility again, rather than on value of time savings, which is the traditional measure. And we suggest to use activity-based models as a main tool, because it can be used or reflect main features of the capability approach, as they have the ability to simulate activity and travel pattern for each individual, but also the ability to use the activity-based accessibility measure, what we call OXAM, to estimate the overall benefit from transport investments and policy. And what is very important in equity perspective is that this measure allows one person to have different accessibilities for different choice situations depending on her characteristics. But LogSum or activity-based accessibility measure is not an equity measure, and it suffers from the same problems or some of the problems we are facing when we deal with calculation of consumer surplus. And so it must be combined with other measures. So we started by combining it with subjective well-being measure and create what we call the subjective value of accessibility gain. It's an accessibility-based measure combined with subjective well-being factor. This measure was designed to narrow the gap in evaluation when we tried to capture accessibility, and after that we tried to capture it in monetary values. this factor come to narrow the gap between income groups. But it is in subjective well-being measure or units, so it's not monetized measure. So it must be present along with the cost-benefit analysis. So, but it connects cost-benefit analysis with equity analysis in a systematic way, and we incorporate it in a new equity approach. We call it equity benefit analysis because of this connection. As a second step, after we did that, we decided to look at opportunities or at accessibility in a different way, calculate it in a different way, so it captures actually people's opportunities. And then we created what we call value of capability gain. It's an accessibility-based measure, but it captures people's real opportunity and incorporate it in cost-benefit analysis as a main measure. I'm going to describe it in a little more detail now. So we are in the first measure. As you can see, this is the happiness or well-being income relationship. It is positive and highly significant. And what it implies is that lower income groups will let's say, change their well-being significantly as a result if we invest specifically and improve their well-being. We wanted to capture this effect in the evaluation. As I said, to narrow the gap using this relationship. So while we capture the accessibility, and while we wanted to reflect the consumer surplus, instead of using the marginal utility of income, we use the marginal utility of income together with factor that comes from the same relationship. This factor is, again, come to narrow the gap in income groups when we translate accessibility into monetary values. If we sum it up across all users, we get one measure that can be incorporated in a new evaluation method. As I said, it's called equity benefit analysis. And this will be presented alongside with cost-benefit analysis. But then, to my opinion, it was not enough. So I looked deeper into the capability approach. And if you look deeper, you found that we actually need to evaluate the set of alternatives that are effectively available to the individual, in a sense that a person can make full use of every opportunity within his choice set, which means different people will have different choice sets. And these different choice sets will be relying on their personal, environmental, and social circumstances. If we do that, if we create different choices for different people, then the principle of diminishing marginal utility can be applied on accessibility gains, which means that a person with, well, a person with low income, low accessibility level will gain significant utility compared to a person with high level of accessibility gain. His benefit will be much, much lower as a result of the same project. This is the theoretical framework. So here is the, let's say, opportunity space in terms of travel. So I took Sen's terminology and brought it to transportation. Then we use what Sen called conversion factor. Is the factor or function that creates this restriction that allow us to create different choice sets for different people. So if we look at it in the most fundamental way, it should be a very complex function. And it's, I think, an entire thesis just to reflect this function. But what we want to show here is what different choice sets would make in the evaluation. So once we create different choice sets, then we compute the activity-based accessibility measure or log sum on the new choice set. When we do that, we create an alternative measure to the consumer surplus. We call it consumer capability. So it's activity-based, accessibility-based measure, but it reflects capabilities. Okay, if we sum it up across all the users, then we get one measure that can replace the value of time in the evaluation. I'm going to show you a result of the real-world case study we did. We used the San Francisco Bay metropolitan model, or some, let's say, model that was estimated based on the activity-based model that is used in this region. And this work was done together with Tiara Bills, which was PhD student in Berkeley University. So, as a background, this region includes 9 countries and about 100 cities, 7.5 million people, and it includes three main CBDs. Here is San Francisco, main CBD, Oakland, and San Jose. And we're talking here on complex transportation network. It includes highway systems, bus services, toll bridges, ferries, heavy, light, and commuter rail, very complex transportation system. And this is the activity-based model that was estimated based on this, the data for this region. So as you can see, we have mode and destination choice model. At the lower level, we have a nested logic that includes 3 nests and reflect auto modes, transit modes, drive to transit and walk to transit, and active modes, walk and bike modes. It also includes travel time, waiting time, travel and parking costs, income categories, and tour stops. So the reason why I chose this model is because it is very sensitive to consumers. It includes a lot of variables that related to the consumer. And at the upper level, we have destination choice model. It includes piecewise linear distance, employment by sector, and the log sums that come from the mode choice model. So Tiara found that in this region, the most low accessible and low income people are using the walk to transit and walk bike modes. So in an attempt to capture the effect of our new measure on these populations, we tested the scenarios on walk to transit and active modes. I'm going to present also today, because of time limitation, only the walk to transit result. So we assume some infrastructure improvement that would reflect in 20% reduction in travel time, and we wanted to see how would that affect on the population. So what we did was classify the population into 4 accessibility levels. These accessibility levels were calculated based on the log sum obtained at the top of the model before applying any change. So this would be the basic level of accessibility of a person. Okay? So we have 4 categories, 4 accessibility categories. Category 1 is the less accessible population. Category 4 would be the highest accessible population. And then we calculated 3 measures. One is the traditional consumer surplus, but using activity-based models. So it log sums, monetary log sums, let's say. Then we calculated the log sum, but combine it with the income well-being factor. And the last measure we calculated is the capability-based measure. So to capture a capability, we apply some very simple restriction on the network. So we assume people can choose or can actually use all the destination. You are. So the person can actually use all the all the work opportunities that were within 60 minutes travel time. So we are talking about here work opportunities because the model was estimating using work-based tours. Okay, so with this restriction, we created different choices for different people, okay, because different people can go to different number of work opportunities. The reason why we chose this restriction is the only evidence we found in the literature that that there is some restriction on space when it comes to work opportunities. And these are the results. So we see here the change in consumers' benefit using consumer surplus, traditional measure, value of capability gain, and subjective value of accessibility gain as a main measure. So here you can see the 4 accessibility levels. Again, 1 is the lowest and 4 is the highest. And we'll maybe start with the most interesting results. So as you can see here, the lower the accessibility level using the value of capability gain, the capability gain measure, the lower the accessibility level, the higher is the benefit. If we look at the consumer surplus, the results are just the opposite. Okay, the lowest the accessibility level, the lowest is the benefit for the consumers. If we look at the activity-based combined with subjective well-being measure, we see diverse result. So accessibility level 2 to 4 follow the same trend of the consumer surplus. But accessibility 1, this measure can reflect significantly higher benefit compared to consumer surplus. And this is because most people that in accessibility level 1 are low-income people, so the factor for them is big. And while if we test accessibility level 2 to 4, we see mixed population in terms of income groups. Because accessibility captures not only income, it captures all the travel dimension. So, yes, I want to conclude. So the capability approach and the activity-based models have the potential to provide a more equitable evaluation of transportation project. This is the first study trying to suggest a practical way to use the capability approach in transportation. Result indicates that the new 2 measure can reflect higher benefits to more vulnerable population groups, and the benefit evaluating under the traditional method are mainly sensitive to time savings and therefore favor the rich. We discussed disadvantages and advantages of these 2 measures as part of the thesis. And we also found in the real case studies that the subjective value of accessibility gain, this is the measure that combined the income well-being relationship, is limited in correcting the bias that is built in cost-benefit analysis because it relies on consumer surplus. However, the consumer capability measure is sensitive to policies that will add capabilities for traveler that express in destination gain, and therefore the less accessible the population, the higher its benefit. That's it.